Today's lesson will be solving exponential and logarithmic equations. Okay, so here we're basically using the properties that we've already talked about in prior sections to help us solve these. So like here, you have an exponential equation where you have 3 to the x plus 2 equals 7. Now in order to solve this, I need to get the x plus 2 out of the denominator or exponent. I mean, not denominator or numerator. I need to get it out of there, so I need a property that I've used before that allows me to do that. So the power property in logarithms actually allows you to do that. So I need to create a logarithmic equation to do this. So I need to take the log of both sides. Now for logs, you can do ln of both sides, or you can change it to a certain base. It's however you feel about going about it. So I can move this now for the power property purposes. Okay. So now remember, this is a number here. Okay. So I can divide log of 3 to both sides. That leaves me with x plus 2 equals log of 7 over log of 3. And then I can subtract 2 to both sides. So then x will equal negative 0.23. And let's round to the hundredths there. Okay, so that would be my answer. Next example, letter B, we have e to the 2x minus e to the x minus 6. Okay, now here, this one's like a quadratic equation with exponents. So think of e to the 2x or just e to the x as like y. So I could rewrite this equation, say y squared minus y minus 6. So it's just a quadratic, so I can deal with it the same way. So I can factor. So the first term for each would be e to the x, because e to the x times e to the x would get me e to the x. And minus means plus minus. And then factors of 6 that subtract to get me 1 would be a negative 3 and a positive 2. Okay, so now I can set them both equal to 0, like you would any other quadratic when you're solving by factoring. I subtract 2, I add 3, e to the x equals negative 2, e to the x equals 3. Now here I want to be able to get the x out of the denominator, or sorry, the exponent area. So I need to actually take the ln here, because ln has the same base. So it actually cancels out. Oh, whoops. Forgot something over here. Since I do it to one side, I gotta do it to the other side. Okay, now what happens here is that if you notice you have ln of negative 2, if you plug that into your calculator, it says error. So then this one is a no solution. So then the only one I have on the right, or a solution for, is on the right side. Now remember, ln has a base of e, so then those kind of reduce away and leaves you with x. That's one of our properties that we talked about. So then ln of 3 in our calculator is going to be 1.10. And that's our answer. Now, if you have logarithmic equations, you can go the other way. So if you have log equations, you can kind of change them into exponential equations to kind of get the log off of wherever your variable is, because if it's in this area to a log, you can't actually do anything with that unless you get rid of the log. So here, I can change this one to exponential form, where I can move the 2 over. So then that's the base of the exponent of 3. Okay, so like so. and then 2 cubed is 8. And then here, let's add and subtract 8. Okay, so then 25 minus 18 is 17, and that equals x. So that would be my answer. Okay, now sometimes before you can do that, you have to put your stuff together to make one log to be able to change it to exponential function. So notice that it's plus there, so adding two logs together is the product property, so I would multiply the stuff the logs are 2. Okay, now here I can put this to the exponential form because the base is 10, so I could bump that up and then multiply my two parentheses here. So x squared, that gets me 2x negative x, so then I get a positive x, and then a negative 2 equals 10 to the first, which is 10. Okay, so then now if I want a quadratic equation to factor, I need to move the 10 over. Gives me negative 12 equals 0. Factor. First terms are x. Plus and minus means plus minus. And then factors of 12 that add up to 1, or sorry, subtract to 1, would be positive 4 and a negative 3. So then I'd set them separate to each other, or it's set equal to 0. Okay, so here you actually have two answers. Now I would go back and check to make sure none of them give you negative answers. So like x equals negative 4, if I plug that in, this is negative 2 and this is negative 5, so then negative 4 can't be an answer because just like the ln of negative 2 doesn't work in your calculator, neither does log of negative 2 or log of negative 5. If I plugged in 3 plus 2 would be 5, so I get log of 5. And 3 minus 1 would give me log of 2. Okay, so then that would give me log of 10. When I put the product property to each other, so 5 times 2. And then if you change base over, it would be 10 equals 10 to the first, which is 10. Okay, so then x equals 3 is a viable option. Okay, so sometimes you have to check your answers to kind of see if you're correct. Also, another one I wanted to kind of show is if you have log of something and log of something else on another side, but they have the same log, or they're to the same log with the same base, then one of those properties, you can add the log, but you can also take it away. So you can get an equation that's just x equals y. So if you ever have logs on both sides, combine them so there's one log on the left and one log on the right, and then you can just take out the logs and rewrite new equations. Okay? Have fun.